But we've got a big one for you tonight. We're going to cover variation, so both inverse and direct variation. And then we're going to cover a translation review. And this is a big one for us. A lot of us have forgotten our vertical shifts, our horizontal shifts, our reflections over the x-axis and the y-axis. So it's in your hands tonight. Take good notes and we'll see you tomorrow. So let's start off with direct variation. They're going to say y varies directly as x, and k is the constant of proportionality. So let's get that formula down. Y equals kx. Okay, so again, k is the constant of proportionality, and my two variables are x and y. Now, many times they like to switch the variables from x and y, so I just want to be clear. Whatever they start with is going to come first. Is proportional is my k, my constant of proportionality, and what it's proportional to. So let's try an example. Number 1. Variable m varies directly with p. So I'm going to stop right there. This sentence right here should tell me the formula I want to use. The key word to me is varies directly, so I start with y equals k times x. Okay, so again, this is my formula for direct variation. Now I want to be clear, my two variables are y and x, and k is my constant of proportionality. Now you'll notice they don't use an x or y. They say m varies directly with p. So instead of using y, they start with m. So I'm going to rename this as m equals the constant of proportionality times p. So your first step is to rewrite this. Now, they'll give you one piece of information to use together. When m is 75, p is 10. 75 equals k times 10, and I can easily solve for k. So 75 divided by 10 equals k, and that is my constant of proportionality. Now I'm going to go back to my equation. M equals 75 over 10 times p. Okay, so my goal is to solve for k and then substitute it in. Now it says, what is m when p equals 16? So m equals 75 over 10 times 16. And hopefully we get m equals 120. So hopefully pretty straightforward. And we were pretty good at this when we did it back in our notes a while ago. But again, start with your formula, switch it to the letters in the problem, and then substitute as you go. Remember, you're always finding k. K is the constant of proportionality. Now, my other option is to say varies inversely. In this case, I would say y equals k divided by x. Okay, so varies inversely means that my two functions, x and y, are doing things in opposite direction. If one's increasing, the other one is decreasing. If one's being multiplied by 3, the other one's being divided by 3. They're doing the inverse of each other, or opposite of each other. So let's go through a nice example. R varies inversely with t. So again, I'm going to start with my generic formula, y equals k over x. And now I'm going to turn it into the variables they use. R varies inversely as t, so keep them in the same order. R equals k over t. I want to stress you are not touching the key. The two variables are the x and the y. Okay, again, k is the constant. You cannot change a constant. And now just plug and chug. When r is 168, t is 24. So 168 equals k over 24. K equals 4,032. Okay, substitute that nicely in. So I've got r equals 4,032 over t. And now it says find r when t equals 30. So r equals 4,032 divided by 30. R equals 134.4. Okay, so those are our two formulas, direct and inversely. So you just have to read and put it in terms of your own variables. So again, let's just compare the two. My direct variation was y equals k times x. And notice this is linear. Okay, this is the equation of a line. K is my constant of proportionality, or the slope of this line. And you'll notice that you're not adding anything here, so I should have a y-intercept of 0. It should be crossing the y-axis right at 0 there. Okay, and you can see this is a direct relationship. As one function, if x increases, then y increases. If x decreases, y decreases. They do the same thing. They directly relate one another. And again, k is that constant of proportionality. Now in inverse, it's y equals k over x. Okay, you'll notice that these are doing opposite things. As my hours increase, my miles per hour decrease. So as one increases, the other decreases. Okay, they are doing inverse relationships. They're going against each other. And again, that k is the constant of proportionality. The only things we're changing are the x and the y. We cannot touch the constant. All right, let's try another one. Variable t varies directly with the square of m. So I'm going to start with my generic formula. Direct was the key word, so y equals kx. Okay, now switch it in terms of the problem. What varies directly with what? Don't touch that constant. You're changing these two. It says t varies directly with the what of m. What do they want you to do to m? Square m. Okay? Now once you have that formula, it's pretty straightforward. When t is 8, m is 2, so that's 2 squared. So we can easily figure out our constant. So I've got 8 equals 4k, therefore k equals 2. And now substitute that in, so I've got t equals 2 times m squared. It says find t when m is 4. So t equals 2 times 4 squared. Order of operations, say 4 squared is 16 times 2. I hope you get t equals 32. All right, our next big topic today is called transformations. And we should be able to transform graphs all over, whether it's vertically or horizontally. We should be able to shift all sorts of graphs. So let's start with a few parent functions. Okay, so they are actually called parent functions, and there's several that you should know without a calculator. And here they go. Your first parent function is you should know what the graph of y equals x squared looks like without a calculator. Okay, so just say to yourself, x squared makes a parabola centered at the origin. And label this point 0, 0. Everything is about that special point. The second parent function you should know is y equals the absolute value of x. And again, you should know this graph without a calculator. Absolute value starts at the origin, and this time makes a V. And we've talked about this earlier in the year. The third parent function would be y equals radical x. Okay, this one too starts at 0, 0 and grows nice and slow like this. Our fourth parent function is y equals e to the x, also known as exponential. And exponential is very special. It grows fast. It starts small and then it grows fast. And its special point is 0, 1. Okay, now this one's even more special. It has that horizontal asymptote at y equals 0. Your fifth parent function you should know is y equals the ln of x, or natural log of x. And this one is the inverse of an exponential. So if exponential crosses at 0, 1, natural log crosses at 1, 0. And this one grows slow. And we talked about that last week. And this has a vertical asymptote known as x equals 0 when it's vertical. Now, I would say these are the main parent functions that we should know. There's 5 of them, and hopefully you're pretty familiar with all of them. I think probably maybe the least one you might be familiar with is the square root of x, so make sure we get that down today. But you'll notice they almost all have that point 0, 0, except for e to the x, which is 0, 1, and ln of x, which is 1, 0. Now, let's talk about our shifts. Y equals, I'm going to say parentheses, x plus, I'm going to go with an h squared plus v. And I want to talk about what these stand for. I want you to kind of box this term in here. Notice that it's inside, and it's very important that we get this down. Anything inside, whether it's parentheses, absolute value, under a radical, any of these, okay? Let me add exponent. All of these represent, when they're inside, a horizontal shift. Okay, and the horizontal shift is going to go in the opposite direction. Likewise, anybody that's outside, okay, so let's make this very big and bold. If it's outside, this represents a vertical shift. Outside is a vertical shift. So you should be able to graph many of these functions without a calculator. And in fact, that's going to be a question on some of our multiple choice. They're not going to give you the function, so you can't graph it. So let's take some quick examples here. Number 1, y equals, let's say, x plus 2 squared. All right, and we want to graph this without a calculator. So here's what I say to myself. What does the parent function look like? This is really just a graph of x squared. So I know my parent function is just a parabola. And the special point on the parabola is that point 0, 0. Okay, and now I'll say to myself, what shift is taking place? Where is the 2 sitting? Is it inside or outside? Clearly, it's inside the parentheses. That implies, that's our symbol for implies, that this is a horizontal shift. And in a horizontal shift, we're going to go the opposite direction. So if I see a plus 2, I'm going to take my point 0, 0, and I'm going to shift it right 2. So go to your graph, shift it right 2, and you're just moving your parabola sideways. Okay, and that's all we're doing. We're starting with the parent function, and we're moving that special point whatever direction it says. That easy. Let's try another one. Y equals the absolute value of x plus 3. Okay, let's get our graph sketched. All right, so ask yourself, what is the parent function? Okay, start with absolute value of x. Absolute value makes a v. I'm going to put it in nice and light, v at the origin. Okay, now where is the shift? Is your 3 inside or outside? Okay, hopefully it's clear that it's outside, which tells me it's a vertical shift. So take that special point 0, 0 and shift it up 3. And we'll make our new graph. And that's it. That is our new function. Let's try another one. Let's say y equals e to the x plus 6. Okay, so we'll start with our graph. E to the x, we'll get it in nice and light. E to the x is special, it crosses at the point 0, 1. Again, I'm going to put it in nice and light. Okay, that's my parent graph. Now, where is the 6 sitting? The 6 is outside. So that's going to shift my graph up 6. Now notice, this time I'm at 0, 1, so I have to go up 6. 1, 2, 3, 4, 5, 6. What is my new point? I would say that's now 0, 7. And that's where my graph just shifted up to. Okay, notice that that asymptote should be one place behind. And we'll graph it in. Okay, so just be very careful. All right, next one. Y equals x minus 4 squared minus 2. All right, so start by asking yourself, what does the parent function look like? I see a squared, so this tells me I should be making a parabola. So again, I'm going to put it in nice and light. Here's my parabola at the origin. And now I've got to shift it. Okay, the -4 inside is telling me horizontal shift right 4. This -2 outside is telling me vertical shift down 2. So take that center point 0, 0 from your parent graph. We're going to go right 4. 1, 2, 3, 4. And then we're going to go down 2. So that's my point 4, -2. And I'm just going to make a new parabola. Okay, and that's the shift. That's all I'm looking for. Which direction am I moving? Okay, so here's a prime example of why you can't use a calculator on some of these. So they're giving you this function, and they're telling you this is what f of x is. And we want you to do 3 things to it. So let's start with the one in red. I want you to take this function and shift it 2. Now, am I telling you a vertical or horizontal shift of 2? Look where the 2's sitting. I hope you've got a vertical shift of 2. So basically, you're going to take all the points you know, and you're going to shift them up 2. So for example, this point here is 0, 1, and I'm going to shift it up 2. So I'm going to make a new point. This point was 1, 3. I'm going to shift it up 2. And I'm just taking the points that look obvious and shift them up 2. And then we're going to smoothly connect them. And it should look like you just picked it up and shifted it up 2. And then let's label that f of x plus 2. So we've got vertical shift of 2. All right, let's try the one in blue. Where are they telling you to shift this graph? Notice the 3 is inside. Inside is a horizontal shift. And remember, you're going to do the opposite of the 3. So you actually want to go left 3. So go back to your original f of x function, your black function here, and we're going to shift it left 3. So again, just take the obvious points and move them left 3. So I'm going to start with this guy, 1, 2, 3. I'm going to move him here. Shift this guy, 1, 2, 3. Shift this guy, 1, 2, 3. And again, connect. Notice I shouldn't change size and I shouldn't change shape. These are just shifts. All right, we've got one more to go. This time we're going to do 2 things. Look where the 4 is sitting. Hopefully you're shifting a horizontal shift 4. And since this was a -4, you should be going right 4. And this 3 is outside, which is telling you to go a vertical shift of down 3. So pause it, graph it, see if you get the same thing. So I went down 3 and right 4, down 3, right 4, down 3, 1, 2, 3, and right 4, 1, 2, 3, 4. And again, I shouldn't change size or shape. I'm just doing some shifts. So hopefully you've got the idea between horizontal and vertical. Lastly, I've got one more translation for you. If I say negative f of x, I'm really saying take a negative, and this is fancy for y. If you negate the y, if you make the y negative, this is a reflection over the x-axis. Now compare that to this term. This one says f of negative x. This time I made the x negative, which means it's a reflection over the y-axis. Do you see how it does the opposite variable? If you make the y negative, you reflect over the x, and if you make the x negative, you reflect over the y. Alright, our last example for tonight, we're going to graph 2 things. We're going to graph negative f of x and f of negative x. So you'll notice in red and blue here, I have f of x graphed. Okay, so in black, I'm going to graph negative f of x. So all you do is you say to yourself, is you're making the what value negative? Well, negative f of x is saying make the y value negative. And if I make the y negative, that's a reflection over the x-axis. So here's my x-axis. Picture taking this piece and flipping it over the x. Can you think about what that's going to look like? I would think it looks something like this. And I want you to label that negative f of x. Okay, now we're going to do the same thing. We're going to graph f of negative x. So say to yourself, I'm making the x negative, which is a reflection over its opposite, which is a reflection over y. So here's my y-axis. And again, picture taking this blue f of x and flipping it over the y. I would say that it looks like this, f of negative x. So we've talked about several transformations tonight, whether it's a vertical shift, horizontal shift, a reflection over the x, and a reflection over the y. Hopefully you've got some good notes and you can keep these all straight, and we'll look forward to some review tomorrow. Have a great night.